Good day everyone, I'm Chia Zhengzun and along with my teammates are Li Yuan, Lim Jialeong and Chiang Yuzing. Today we will present our lab project on implementing a synchronization mechanism for reader-writer threads using mutexes and semaphores. This is the initial part of our code. Our goal is to actually allow multiple readers to access the shared file concurrently, but at the same time ensure writers have exclusive access. Therefore, we enforce two situations. Firstly, where writers can block both readers and other writers. And secondly, readers can block writers but not other readers. Moving forward, these are the functions and methods utilized and implemented in our code. They are writer, reader, lock, unlock, acquire, release, thread.sleep, main, and last but not least, interrupt.
For our project, we implemented two core thread classes, the writer and the reader. The goal of the writer class is to gain exclusive access to the shared file, simple.txt. Before a writer can write, he must acquire a single semaphore lock which we name rwmutex. This lock ensures that while the writer is active, no other writer or reader can access the file. This piece of code refers to the lock statements that will be presented as output in the terminal while the writer is writing. After the writer finishes writing, the mutex lock is released. Next up, we have the reader class. The reader class is designed to allow multiple readers to access the file at the same time. It uses a more complex two-level lock system, namely mutex and rwmutex. A mutex lock is used to protect a counter that tracks the number of active readers. The first reader to arrive is responsible for acquiring the main rwmutex lock. Lock statements are also presented when one or more readers reading the file. When the last reader finishes, it releases that main lock, allowing a waiting writer to proceed. This approach successfully allows concurrent reading while ensuring writers always get exclusive access to the file.
I will now explain how we use synchronization methods in multi-threading, lock, acquire, unlock, release, and thread sleep. So first, lock and unlock come from the retrain lock class in Java. We use lock when a thread wants exclusive access to a critical session like accessing shared data. So once done, we call unlock to allow other threads in. So similarly, acquire and release are used with a semaphore. Acquire tries to take a permit, and if not available, the thread waits. So release adds a permit back signaling that a resource is free. So for the last thread, sleep is used to pause a thread for specific time.
Now, let's focus on the main function, which is the entry point of our program. I would like to highlight the part where it announced the creation of 3 reader threads and also 2 writer threads. These thread objects are created and stored in an array list. Finally, the program iterates through the list and calls the start method on each thread, which begins their concurrent execution. Next, after starting the threads, the main program waits for the user to press enter. Once enter is pressed, the shutdown sequence begins. The volatile boolean flag name running is set to false. This actually acts as a signal for all the threads to exit their main loops. We will then call interrupt method on every thread. This is crucial because it awakens any threads that might be paused by thread.sleep method or waiting on a lock, where allowing them to check the running flag and terminate properly. This two-step process actually ensures that our program closes without any errors.
Next, we will continue with our first test scenario. Here, we can see that the writer 1 start writing and successfully appends the data into the file. So here we can also notice that the writer 2 is immediately put into a waiting state. So it demonstrates the principle of exclusive writer access, and the system correctly enforced mutual exclusion, ensuring that only one writer can modify the resource at any given time to prevent data corruption. Moving on to the second scenario, and this test shows that while writer 1 is active, no other readers are allowed to access the file. Only after the writer 1 finishes its task, then only the 3 waiting readers begin. In scenario 3, shows that when readers are active, writer 2 is forced to wait, so it can only proceed after the last reader has finished. In the last scenario, it demonstrates the concurrent reading. We see the 3 readers accessing the file simultaneously without blocking each other, which maximizes efficiency for read-only tasks.